Moving on to block 2 and topic 8 of equations and inequalities on page 227. Yesterday we looked at the Sadko family of alien invader people. Today we're going to look at the Sadko family of aliens. They look a little different but kind of the same. And it says family member number 1 has 2 body sections and 3 hairy legs. Family member 2 has 4 body sections with 3 hairy legs. Family member 3 has 6 body sections and 3 hairy legs. So number 1 in your workbook says, what do each family member have that is the same? So, what is something they have the same? Yes, sir.
3 hairy legs.
How many?
3 hairy legs.
They all have 3 hairy legs the same. So I'm writing that for 1A. The same, they all have 3 hairy legs. Then they wanted to know what is different about each of them. What do you see different about each family member? Yes?
Like the first family member has only like one little hat, has a hat, but then the second family member has kind of still the same exact amount of hat, but like more blocks.
Okay, well they're calling those 3 hairy legs. You see the 3 hairy legs? The 2 on the side and 1 on the top. So that's what they all have in same. The 3 hairy legs. The 3 edge pieces. So they have those in same. What's different?
What's different about them is that each don't have the same size body or hat.
They don't have the same size body section.
Each are increased by 2.
Okay, they're each increased by 2. I'll agree with that. So family member 1 has a body section of 2. Family member 2 has a body section of how many? 4. And family member 3 has a body section of 6. So what is different about them? They all have different size what?
Bodies.
Different size body sections. Writing that for 1A. They all have different size body sections. Okay, 1B says to sketch the 5th family member. So off to the side in the empty space right there, we see family member 1, 2, and 3. They want to know what the 5th guy is going to look like. Not the 4th, but the 5th. So in the empty space right there, sketch what you think the 5th guy would look like. Sketching what you think the 5th guy would look like. We know something they all have the same. They all have what?
So they all have two
How many hairy legs do they all have?
3.
3 hairy legs. So we know our 5th guy better have 3 hairy legs. He's just going to have a different size body section. size body section do you think he has?
8.
8?
I think his body mostly would be like 13.
Like the whole thing.
No, just his body section. How big would that be?
It's 8.
8? 10? Okay, we're looking at the 5th member. Boys. The first member, what's his body section? 2. Second member, his body section is 4. Third member, his body section is 6. The fourth member, what would his body section be? 8. So what body section should the 5th member have? 10. Said to find the 5th guy. So his body section should be 10 with how many hairy legs? 3, giving him a total of how many body parts? What's 10 plus the 3 legs? 13. Okay, what you got, Chance?
Wait, did you tell us to find the 4th one or the 5th one?
The 5th?
Oh.
I tried to enunciate so you would hear me on that one. Alright, so we are looking at our people. We had the 2 body sections, 3 hairy legs of the first guy. Second guy had a 4 body section with the 3 hairy legs. Third guy had a 6 body section with 3 hairy legs. Okay, we now want to put that into a table. I think they did for us already on the table on 1C. They did what family members already? 1, 2, and 3. And how many body parts did family member 1 have? 5. Family member 1 had a total of 5 body parts. Where did they get 5? Where did this plus 3 come from? The hairy legs. Where did this 2 come from? The body. Where did the 1 come from? He's the first member. That's his name. He's the first one. Okay? So, is the second member going to have a 1 there? No. Is he going to have a times 2? Yeah. Is he going to have a plus 3? Okay, so the second member has 2 sets of core bodies plus his 3 hairy legs, which gives us a total of 7. Third member has 3 sets of cores plus the 3 hairy legs and gives us a total of 9. So what is the same throughout here? The process. The plus 3. What else is the same? The times 2. That's going to help us write our equation. So going down to the very bottom of your chart, we're writing our equation. So our equation could be 2x plus 3 or x times 2 plus 3 equals y. That's the very bottom of our chart on 1C. But our chart wants to know how many body parts family member 5 has. We already found that. How many does 5 have? 13, but we need to fill that into our chart. That is family member 5, so we could use our equation and plug in a 5 for x. So our process could be 2 times 5 plus 3. Does 2 times 5 plus 3 give me 13? Yep. So that is what we need to fill in for our table for 5. Alright, when you're done writing that, let's flip to the back where D is located. And it says to plot the points for each family member on the graph. Well, first I need to label my X and Y axis. My X axis is labeled family member number. Write that. I see some people graphing and not writing the titles. Family member number is the X axis. The Y axis, total number of body parts. Now they want us to graph the family member 1, 2, 3, and 5. So family member 1, I have an ordered pair of 1, 5. I need to plot that. Family member 2, I have an ordered pair of 2, 7. 3, I have an ordered pair of 3, 9. And 5, I have an ordered pair of 5, 13. So your graph should look similar to mine. Can I use a graph to answer questions if they ask me questions about the family members? Okay? What if I asked how many body parts does family member 4 have? What would you say? I want to use the graph.
Can I explain it?
Chance, explain it.
Okay. Just gonna take a little bit. Okay. Like when it starts at 1 to go to 5. Okay. I'm just don't know this is right, but it goes, and then when it goes to 2 to it goes to 2 to 7. And when it goes 2 to 7, it's like it goes up by 2, and then it does the same thing again. So it could be 4 over 11.
So you think family member 4 would have 11 body parts?
Just because.
Okay, I want everyone looking up here. For family member 4, which is this line right here, going all the way up, would it make sense for me to have a dot located about right here?
No.
Would it make sense for me to have a dot located here?
No.
Here?
No.
Here.
Yes, ma'am.
What tells you that a dot needs to be here rather than down here somewhere?
There's a big gap right there.
Oh, there is a big gap right there. Okay, so what's telling you that is that your mind is envisioning a line going through those points, right? So I can predict that 4 would be located there. However, I can't draw a line, I just have to imagine it. The reason I cannot draw a line, listen carefully because this is a big thing for 8th grade and 9th. The reason I cannot draw a line, can I have, a line indicates I can have decimals because all of these amounts in between those tick marks is decimals. Can I have a decimal part of an alien?
No.
You either have an alien or you don't have an alien, right?
You don't want to
Same thing if I was talking about people. Can I have half of a person?
No.
No. You either have a whole person or no people at all. So this line right here, if I drew a line, I'm saying that I can have half of an alien. Can I have half of an alien in this game? No. Can I have 2.5 of the aliens in this game?
No, ma'am.
No. You either have whole aliens or you don't have them at all. Okay? So I cannot draw a line unless the decimals make sense with the problem. When is some cases where decimals are okay in a problem?
When you're trying to plot coordinates.
Yeah. What real world stuff would make sense to have decimals?
Baking.
Baking, I can have decimals, so if I'm graphing some ingredients, Money deals with decimals, so it's okay to draw a line with money because I can have decimals.
You're telling me you can have a
I'm sorry? Construction, like measurements and stuff, I agree.
Bricks, because how they cut them a lot of times.
Okay, if you're getting very specific with bricks. If I'm buying, if I am counting apples from a tree, can I have decimals?
No, ma'am.
No, you either have a whole apple or no apples at all, right?
Yes, ma'am.
If I am selling the apples, can I have decimals?
Yes, ma'am.
Because I'm now dealing with money. Okay, so that's where a line makes sense with the problem. Moving to problem 2, we came up with a rule as 2x plus 3 equals y. And we want to use that to see which family member has 13 total body parts. Well, looking at your chart, what member has 13 total body parts? Member 5. But if I didn't know that, I could plug 13 into my equation. What does X stand for in my table? I have some people staring off and not focusing.
Family member numbers.
X stands for family member number. What does Y stand for? Number of body parts. So if I say I have 13 number of body parts, am I plugging that in for X or Y? So if I did not know the answer was 5, I could plug 13 in, and I could think 2 times what plus 3 is going to give me 13. Well, 25.
2 times.
5.
Oh. 2 times 5 plus 3 gives me 13. But I would have to sit here and try and play around with numbers, right? So we need to learn how to solve that, and that's what we're about to do. It says how many total body parts does the 10th member have? How do I find that? Am I plugging 10 in for X or Y? Family member number, X or Y? X, so 2 times 10 plus 3. What does that equal? 23. So he has 23 body parts. C says write the equation for the 7th member. Am I plugging 7 in for X or Y? X. So 2 times 7 plus 3, what does that equal? 17. What you got, Tristan?
I was gonna ask another topic here, but are we gonna be learning half decimals later on?
Yes. Okay. This next slide is not in your book, but this is an example of a graphing calculator. This is my graphing calculator I've had since I was in high school. It's my baby. If I lost this, I'd probably have to quit teaching math because it would make me cry that much.
Really?
Yes.
How long have you had it?
I know how to work this calculator front and backwards, and it helps me to do all sorts of math problems. It's a graphing calculator, so a graphing calculator can do what? Graph. Well, I can put in an equation into the graphing calculator, and it would graph it for me. What it does is I can look at its ordered pairs, and I can see its ordered pairs graphed on a graph without me having to do all the work on paper. Okay, well, let's look at this table. What did X stand for in our problem? Family member number. And what did Y stand for? Number of body parts, total number of body parts. And there's a Y1 right there, just because in extreme math, there gets to be other Y values, and so they have like Y2, Y3, and you won't get there until possibly college if you take those maths.
It means like.
So,
whatever you get,
it goes like 3D graphs, which essentially is what Minecraft is a 3D coordinate plane. So, anyways, looking at these ordered pairs, what does the ordered pair 411 stand for then? We just said what X and Y stood for.
There would be fourth member would be
The fourth member has
11 body parts.
11 body parts. I could see the fourth member and where he's graphed, and I could make predictions. Okay, so that's how the graphing calculator is kind of nice for us. Now going to, what are we, problem 3? Okay, this is a balanced scale model. We said we were going to start learning about these. They help us to solve equations. Right now, is the scales even? Do they weigh the same?
Yes.
Why do they weigh the same?
Because it's the same thing. One has 4, but the other has 1 and then
They both have 5.
They both have 5. Okay? They're arranged differently, but the weight is still the same. So if I hid 3 of those chips, or I don't know what we're talking about there. Moving on.
Centimeters.
Oh, I wanted to go back to that actually. So, I remember what I wanted to say with that. We're going to pretend this blue cup here doesn't weigh anything. Only the blocks weigh stuff. And we're going to hide some blocks in the cup. And we have to figure out how many blocks are hidden in the cup. So that's our goal here, to solve the problem. Scroll down. There. So this looks like your problem for number 3A, correct? Okay. I have 4 blocks on one side, 1 block, and a cup of hidden blocks on the other side. Obviously, we're smart to know how many blocks are hidden on the other side. How many is hidden inside the cup? 3. Okay? But we need to see mathematically how we got there. So, we're going to take that problem, and we're going to take 1 block away from the scale. Is it still equal?
No.
The scale's not equal? I took 1 from both sides. So, this is what you're writing for 3A. I like seeing my math work written a little different. I like to write it like this, but either way is fine. They both mean the same thing. So we solved that equation and we used the balance beam here to help us solve it. We had 4 chips and 4 blocks and 1 block on the other side. Where'd they go? Where did one of the block go? They took 1 away from both sides. That's why it's still even. So I know that there are how many blocks in the cup hidden? 3. That's why it was even. Okay, let's go to B. B looks like this diagram here. Okay, I have 2 cups, 3 blocks on one side, and I have, what, 15?
15.
15 on this side.
No, I think it's 14.
4 times 3 is 12. 13, 14, 15, huh?
I said 14.
15.
No, I'm at 14.
Okay.
That's what
So, I need to know how many blocks is hidden in each cup. So, last problem, I just got the cups by themselves. So, how many blocks need to be taken off of both sides to get the cups by themselves? 3. So, I'm going to take away 3 blocks. Here in a second, I'll take away 3 blocks. So I took 3 blocks off of both sides. So 2x plus 3 equals 15. This would be my work. Okay. Now I have 2 cups. They each have the same number of blocks. How many blocks is left on the other side? 12. Each cup needs the same number of blocks. So how many is in each cup?
6.
Okay, how'd you get 6?
6 plus 6 is 12.
Okay, what other operation could you have done?
Just
Times 2.
I don't know.
I could have divided 12 by 2. So looking at my work over here, divide 12 by 2, and x equals 6. So each cup should have 6 in each cup. And they did. Chance.
I heard that method.
Yeah?
All you really have to do is like since there's 15 on this side, so there's 3 right here, and there's 3 right there. So all you have to do is just really, because like you automatically know it's 15. So 5 and a 5 can't really do that. It's 13. So if you move up one, then that is 16.
Okay, well, here's the problem with common sense and having to know my method or the mathematical method is common sense, Chance. Solve that.
Can you give me a minute? Can I go work it out?
Oh, you can. It's common sense. Right? So if you didn't learn this method, it's impossible to solve this common sense. Which is, this is next year. Okay? So, we're getting to this, but we can't do that yet until we've got this method mastered of the simpler stuff. Alright, so, moving, what are we on now? 4? Oh. So, number 4,
How many boards is that?
says that we had an equation established for the, what's the family name here? Sadko Family, which is 2x plus 3 equals y. And we want to know the 27, what family member has 27 body parts? So, what stands for body parts? X or Y? Body parts?
No,
Why?
So I'm going to plug a 27 into my equation for y. So this should be written next to your picture. 2x plus 3 equals 27 next to your picture. Michael? No, you haven't. Okay. Inside. Okay, I'm gonna use this diagram to help me solve this. What needs to go away first to get my cups by themselves? 3 blocks on just one side? Both. So this needs to disappear. Okay, well, I don't want it yet. So 3 blocks on both sides disappeared. My scale is still balanced. Showing that with my math, 3 blocks are going away on both sides. And how many blocks is left over there? 24? Okay. So now I need to divide it into how many groups? How many cups do I have?
2.
How many groups do I need to divide it in then? 2 groups. So I'm going to divide into 2 groups. So I'm going to divide by 2. How many blocks are in each cup? 24 divided by 2.
7.
Are you listening? 24 divided by 2. 12. So how many are in each cup? 12 is in each cup. So the balance beam kind of helps us remember how to solve these problems.
I calculated
Yeah, just a little bit. That's why I kept saying 24 divided by 2. 24 divided by 2. Okay. So it's A says which family member has 27 body parts? What family member has 12? Family member 12 has 24 body parts. Wait, 27 body parts. Okay, B says, can there be a family member with an even number of body parts? Look at the table. Have we found any family member with even so far? Even number of body parts?
No.
No, we have not found any family member with even body parts. Could we have a family member with even body parts? All right, for a bonus point, raise your hand. Why can we not have a family member with even body parts? She was the first to raise her hand.
No, because 2 is even, so your answer will be even, but then you add 3, which is an odd number, so the number of your body parts will be odd.
Where we were adding how much every time? 3. So that means we could never have an even number. Anytime we add 3 to anything, am I going to have an even number? No. I'm going to have an odd number. So the answer to B is no, because we add 3 every time. 3 hairy legs. So B says no, because we add 3 hairy legs every time.
Wait, is that why we were adding 3? I was wondering why.
Yes. And you were out for that. Or, so my next slide here just shows all the methods we could use to find the same answer. I could look at a table to find my answer. I could look at a graph to find my answer. Or I could solve it with an equation. Didn't we just use all those ways?
Yeah.
Yep, and some of them was easier than others to find. Do what? No. Okay, looking at problem 5 and 6. 5 and 6 I assigned online. Problem 5, you select a problem and then you work with the beam to solve it. Okay, That's problem 5. Flip to problem 6. Problem 6, they tell you a problem, and you have to put the numbers in the correct spot and solve the problem there for each problem. So you're showing your work in your workbook, but you're using the online stuff to help you. Then problem 7 and 8 is in your workbook, not computer. Okay, so the rest of the time, you can either get a device and work on 5 and 6, or you can work on 7 and 8. I don't have your process paper yet, so we're going to hold off on more practice.
So we don't do it online right now.
Well, block 2 is online. Hey, thanks for listening. Have a great day. Like, subscribe, hit the notification bell, and peace out, homework.
Bye.